And before we get started, just really quick, everybody's eyes on the screen. Okay, a quick intro. So we're done with expressions. We already finished polynomials, your favorite, right? We already finished with numerical and algebraic, right? We started with properties of real numbers and so on and so forth. Today we're starting with equations. So in regards to equations, who's seen something like this? Everybody look up to the screen. Show of hands. Okay, this is what we call a scale. Okay, now if we were to exist back in the gladiator days, all of us will be wearing robes, right? Oh, yeah, or togas, my bad, togas, and then some cilantro right here in our hair, or whatever the case. However, back then, in order to buy and sell products, they used scales, which now they have them at the grocery store, but they're a little bit different than this. However, if I was to go to the grocery store and I wanted to ask for 8 pounds of something, so they, on this side, they add weights. Have you guys seen those weights? They look like copper. Some look a little bit dark, and they're like really heavy. They look like hockey pucks. Oh, yeah. Okay, well, those, they use them, and they can place them here. So imagine they place 8 pounds here, and I wanted to buy 8 pounds of beans. So therefore, they place the bag right here, because I want 8 pounds of frijoles, right? So therefore, they start pouring in here the beans. So what's going to happen once it reaches the 8 pound mark? It's going to even up, right? Well, guess what? Equations are the same way. That's why in the past, your teachers have told you whatever you do to one side, we need to do to the other side. And pretty much it follows the same thing as a scale. Everybody with me? When we get to inequalities, I'm going to show you something also with the scale that's going to have you remember the inequality symbols for those that struggled last year. Okay, so that's pretty much what we're going to be doing today. And the purpose of introducing them like this, because we're going to be using properties again. Remember this here's the how and the why, right? All right, so here we go. So with that said, our objective for today, I can solve and graph one variable equations. Let's read it together. 1, 2, 3. I can solve and graph one variable equations. All right. So we have a new concept for today. So think about it. What's our concept for today? And tell your neighbor. Concept for today. Okay. Very well. One variable equations. One variable equation. So on your handout, make sure you underline or circle with red where it says solve and graph, and where it says one variable equations, underline or circle with green, please. And as a title for your notes, make sure you write one variable equations. One variable equations. Okay? All right, let's continue. So, one variable equations. Let's clarify it from right here on so that we know exactly what they are. It says, mathematical statements where two expressions are equal to each other and contain one unknown variable. Okay? So yesterday we did an introduction, again, in regards to expressions. Remember? When we did numerical and algebraic. Remember that? Okay? So the examples that I give you for one variable equations are these. X plus 2 equals 25, 12 equals y minus 8, 2a equals 14, and negative 3 equals m over 4. Some more examples that I gave you, then there it's 3x plus 2 equals 25, 12 equals 4y minus 8, 2a plus 8 equals 14, and negative 3 equals m over 4 minus 6. Okay? Now, before I go, well, let me go to the non-examples. Copy these non-examples, please. Non-examples. X plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, and 4x plus 6 equals negative 2y. Okay, so according to the definition says Statements where two expressions are equal to each other and contain one unknown variable. So pens down really quick, eyes up here. Check this out. So let's look at this one. If I was to cover this part, okay? So check this out. Is this an algebraic expression? No. Yes, because it has a variable, numbers, and operations. Remember we covered that yesterday. If I was to cover this part, is this a numerical expression? Yes. So now, if I was to take this away, is an expression equal to another expression? Yes. According to the definition, it says statements where two expressions are equal to each other. Are these two expressions equal to each other? Yes. Does it have one unknown? Yes, here it is. If you look at the rest, they're about the same. Expression equal to each other, and so on and so forth. So, looking at the none examples, think about it. So, think about why these are none examples. Think about it first. Why are these none examples? Okay, talk it over with neighbor, please. Why are these none examples? Most important thing to remember about one variable equations is that they have an equal sign, number one. Number two, that they have an unknown variable. And let's add the last one, exponent of 1 on the variable. Okay? So, three things to remember about one variable equations is number one, they have equal signs. Okay? One unknown variable, yes, they have one unknown, bless you. And the exponent of 1 on the variable. All variables have exponents of 1. If it has anything greater, then it's not a one variable equation. It could have, but for this lesson, we're looking at equations that do not have exponents greater than 1. Bless you. All right, let's continue. Steps. Number one, simplify each side of the equation. Start with grouping symbols and combine like terms. So word to circle there is simplify. Circle that. Okay. So simplify each side. Step two, isolate. Which means what? Isolate to leave the variable by itself, right? Okay. Put the wiggles on inverse operations, because that's what we're going to be using. Bless you. Step three, plot on the number line. And step four, check your solution. So let's see. Simplify each side of the equation. Start with group symbols and combining like terms. Step two, isolate the variable by using inverse operations. Step three, plot your solution on the real number line. And step four, check your solution by substituting the value of the variable into the original equation. Okay? And with one-step equations, we're going to see two of them today. We're going to see the one-step and two-step equations, but we already did this before, right? You did this in pre-algebra, and you guys were experts at it. You loved equations, right? All right. So with that said, let's think about our steps. So step one, simplify each side. Step two, isolate. Step three, plot. Step four, check. Step one, simplify. Step two, isolate. Step three, plot. Step four, check. Let's go a little bit faster. Simplify, isolate, plot, check. 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 Tell your neighbor the steps, please. All right, so with that said, here's your Cornell notes. So one thing to remember, I'm going to have you write over here on the Q side, please. And with red, we're going to write, well, actually, let's do this with blue. First, right here, since this is what we're going to be using throughout, write operation. Write it kind of with small font, please. Operation. And over here, we're going to write inverse with red. So just to refresh in your memory, here we go. If I have addition, turn to your neighbor, let them know what will be the inverse operation of that. Okay, thank you. Everybody said subtraction. Okay, so what if the original operation was subtraction? So therefore the inverse will be addition. So what if the original would be division? So therefore, what is the inverse? Multiplication. I'm just going to use a big dot. Since we're going to be using more variables now, I want you to start using the big dot, please. Okay? All right. And if our original operation was, was multiplication, therefore, the inverse will be division. Okay? And the last one. Everybody look up, please. If the operation is, and this is for future reference, we're not going to use that for this lesson, but so that you know. If they want us to take the square root, what is the inverse of taking a square root? Raising to the second power. That's the inverse. And the same goes with what if it's a cube root? What is the inverse? Raising it to the third power, and so on and so forth. Okay? All right, with that said, let's continue. So let's start by solving these. Now these, like I said, these are fairly simple, but I want them done in a specific way, right? So step one was simplify each side. So is this side already simplified? Can I do anything else here? No. How about this side? No. 25, you can't do anything to 25. So now, step two, we need to isolate the variable, which means we need to leave it alone by using what? Inverse operations. So we have x plus 2. So what is the inverse of plus 2? Minus 2. And whatever we do to one side, remember the scale? We do to the other side. These cancel. I bring down the x. What is 25 minus 2? Michael Jordan. That's right. 23. So it was simplify, isolate, plot, and check. So now we need to plot our answer. So check this out. Get a number line going right underneath, please. A small one, like so. And my solution for this one was x equals 23. So here's 0. And then 1, 2, ... 23 is about right here. And you need to plot your points. And some of you are saying, why do we have to do this, Mr. Q? Because I said so. No, just kidding. No, I'm getting you guys ready so that when we get to inequality, this is the very first step for inequality. So if we already have the practice, it's going to be easier. Okay? So let's see. Simplify. Did we isolate? Did we plot? So what's next? Check. So we need to check our solution. So therefore, I'm going to rewrite this this equation. I'm going to rewrite it right here. But instead of x, I'm going to write a parenthesis. Open parentheses, plus 2 equals 25. And what goes in the parentheses? 23. So, what is 23 plus 2? 25. Is 25 equal to 25? Yes. And we're done. All right? So, with that said, see if you can do this one by yourself. 12 equals y minus 8. Follow each step, please. So let's see. This says y minus 8. What is the inverse of minus 8 or subtracting 8? Add 8 to each side. This cancels. We're left with y equals 20. From there, we plot our solution. Here's 0, 1, 2, 3, dot, dot, dot. 20 is over here, and there's my plot. Next, we rewrite our equation, but instead of the variable, what are we going to do? Open parentheses, minus 8, and we substitute. What number are we substituting? 20. So we're left with 12 equals, what is 20 minus 8? 12, and we're good. Okay. Now, why is this so efficient? Because when it comes to the homework and when you're doing independent work, if you just work out the equation and you don't check it, you're probably going to get it wrong when we start getting into multi-step. Okay? So make sure you check your answer. Okay, so do this one together. So therefore, how about negative 2? What is it? What is the operation in between the negative 2 and an 8? Multiplication. So to cancel, or I'm sorry, to do the inverse, it doesn't cancel in this case. Negative 2 multiplies, so therefore the inverse is to divide by negative 2. And whatever we do to one side, we do to the other side. So what is negative 2 divided by negative 2?
1.
1. What is 1 times A? A. And what is 14 divided by negative 2? Negative 7. Okay? We plot our answer on the number line. Zero, 1, 2, 3, 4, 5, 6, 7, and you plot your point. Oh, my bad. I was doing it to see if you were paying attention. 1, 2, 3, 4, 5, 6, 7. Negative 7. And plot your point. All right. So let's check our answer. So we rewrite this. Negative 2, open parentheses, equals to 14. And instead of the letter A, we're going to substitute what value? Negative 7. So are these the same sign? Yes, negative and negative. So what is 2 times 7? 14. Is 14 equal to 14? Yes. Okay, do the next one. Let's see, m divided by 4. So if the 4 is dividing, what is the inverse? Multiply. So that means we're going to multiply times 4. Whatever we do to one side, we do to the other side. So let's see, what is 4? If we multiply this in here, get this out, like this, what would we have? 4 times m is what? 4m over 4, which means what is 4 over 4? 1. What is 1 times m? M. So what is 4 times negative 3? Negative 12. All right, let's plot our answer. Zero, 1, 2, 3, dot, 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 and over here is negative 12, and plot your point. And let's check our answer. Let's rewrite our equation. Negative 3 equals, open parentheses in the numerator, and 4. And instead of that parentheses, what are we writing? Negative 12. So are these the same sign? No. So it's a negative. 12 divided by 4 is 3. Is negative 3 the same as negative 3? Yes. Everybody got it? So with that said, fairly simple, and this is something you guys did before, but I just wanted to introduce the one step. These are one step. How many steps did it take us to solve each equation? Let's see. Right here we just subtracted 2. Over here we added 1. Over here we divided by 2. And over here we multiply times 4. So it's only one step. That's why they're known as one-step equations. Are we there? All right. So with that said, on the right side of that you have plenty of space. I want you to write the following, and you solve these following ones. For these, bless you, for these, just solve them and check your answer. That's fine if we don't plot them. I just showed you how to plot it. So solve and check. Go. Okay. This one, x plus 12. What is the inverse of plus 12? Minus 12 minus 12, subtract x equals to 25. Answer, you got that? Okay. And to check it, we open parentheses, plus 12 equals 37. So therefore, we substitute 25 in there. 25 plus 12, that's 37. Is 37 equals to 37? Yes. Okay. Next, y minus 15. So what is the inverse? Add 15 to each side. 15 minus 15 cancel. We're left with y. What is 28 plus 15? Let's see, 13. We got 1. That's 43. Answer, you got 43. Okay. I rewrite this. This is 28 equals parentheses minus 15. And I substitute what number? 43. So what is 43 minus 15? 28. It's 28 equals to 28. Yep. So far, so good. Next one. Negative 3 is multiplying the a. Is that correct? So the inverse is to do what? Divide by negative 3. Divide by negative 3 both sides. Negative 3 over negative 3 is 1. 1 times a is a. 27 and negative 3. The answer is going to be a negative because they're opposite signs. 27 divided by 3 is 9. So I just rewrite this equation. Negative 3 parentheses equals 27. And I substitute in there what? Negative 9. Are these the same sign? Yes. 3 times 9, that's 27 equals 27. So far, so good. And the last one. M divided by 9. So if the 9 is dividing, what is the inverse? Multiplication. So we multiply times 9 times 9. 9 over 9 is 1. What is 1 times m? M. Let's see over here. Opposite sign, so this is going to be a negative. 9 times 7, that's 63. I'm going to rewrite this equation. Negative 7 equals parentheses over 9. And instead of the parentheses, what am I writing in there? Negative 63. Are these the same sign? Nope. 63 divided by 9, that's 7. Is negative 7 the same as negative 7? Yes. And you got all 4 of them by yourself. Okay? So yes, this is a refresher from last year, so you should be able to do these. Okay? That's why I wanted to walk you through these. So before I move on, check this out. Whenever we are subtracting to each side of the equation, this is known as subtraction property of equality. Check this out. Since we're looking at equations from now on, all the properties that we talk about are going to be for what? Of equality. So if this, we subtracted 12 to each side and it was subtraction property, what is this one where we're adding to each side? Addition property of equality. How about this one? What did we do to each side? We divided by negative 3, so therefore this is what? Division property of equality. I'm just putting these little, not exclamation, quotation, so that we know that it's the same thing as up here. And here, what do we do to each side? Multiply, so this is multiplication property of equality. So far, so good? Okay. So, one-step equations. Let's go to two-step equations. On the back side of your paper, here we go. You have these two, but the steps are the same. Step 1, simplify each side. Let's see. Can we simplify each side? This one's already simplified. We cannot combine anything, and this one's already simplified. Step 2, isolate the variable by using inverse operations. In this case, how many operations do we have? Multiplication and addition. So from now on, whenever we have anything that looks like this, we're going to start wherever there's addition and subtraction. That's where we start. After that, we go to multiplication and division. Okay, and who notices that it's backwards, the order of operations, kind of. Addition and subtraction, and then multiplication and division. You guys see it? Kind of? All right. So let's see. So what is the opposite of plus 2? Minus 2, so we do that to both sides. I bring down the 3x equals 2. What is 25 minus 2? Michael Jordan, 23. From there, what is the 3 doing right here? Multiplying, so what is the inverse? Divide by 3. Divide by 3. X equals. How many times does the 3 fit into 23? 7. That's 21. And how many more to 23? 2/3. Right? From there, if we were to plot it, here's your number line. 0, ... 7 and 2/3 is about right there. And I plot my point. Yes. To get the 2/3 is like this. 23 divided by 3. How many times does it fit in there? 7. That's 21. How many left over? 2. 7 is our whole number. 2 left over out of 3. Okay? What is my last step? Check. I rewrite this. This is 3. And instead of the x, I open up parentheses. Plus 2 equals 25. And then I substitute 7 and 2/3. How about I make it an improper so that I can multiply this number then? What is 3 times? Oh, it's right here. 23 over 3. So let's see. To multiply these, we add 1 right here. What is 3 times? Oh, can we simplify, by the way? Here and here. So we're left with what? 23 plus 2 equals 25. Is 23 plus 2 25? Yep. Is 25 equal to 25? Yeah. Do this one by yourself, please. Okay, here we go. The second one. Where did we start? At -8. What is the opposite or the inverse? Add 8. Add 8. These cancel. We're left with 20 equals to 4y. What is the 4 doing? Multiplying. What is the inverse? Divide. Divide by 4. This is 1. We're left with y equals to 5. Plot my solution. 0, 1, 2, 3, 4, 5. And check my solution. 12 equals 4 parentheses minus 8. And what goes in the parentheses? 5. What is 4 times 5? 20. I bring down the -8 or minus 8. What is 20 minus 8? 12 equals to 12. So was it good? Two-step equations. Okay. Let me move on. Okay, look at this one. This is the last one we're going to cover today. Pens down, please. What do you notice from this equation to the previous ones that we did? We have fractions all over the place, right? Okay, let me show you a shortcut as to not to work. Who likes to work with fractions? Who doesn't? Okay, so check this out. To not work with fractions, to get rid of the fractions, we need to find the least common denominator. What is my least common denominator? 12. So check this out. I'm going to multiply everything times 12. And if I put 12 over 1, that means it's only going to multiply, hold on, it's only going to multiply the what? Numerator. Don't put anything away. Pay attention, please. What is 12 times 2? 24, and I write that over 3, and that's R. What is 12 times 3? 36 over 4. Notice that the denominator stay the same, right? Equals. What is 12 times 7? 84, and I'm going to leave the same denominator. Now, what is 24 divided by 3? 8R. Plus, what is 36 divided by 4? 9 equals. What is 84 divided by 12? 7. Does this look familiar? Yes. So, make sure you do a couple of these in the section of the lesson. Read into it. Okay, so homework is what? Page 82, 1 through 35 odd. Okay, turn in your homework on your way out. Have a good one, guys. Enjoy your homework. See you guys tomorrow. And those of you in the afternoon for tutoring.